Folks, it says that we're live. Hey guys, what's going on? Memes here, and I am joined with Spiral. I got the okay to say Ryan, and he actually recently published a paper on nothing. I never thought those words would ever come out of my mouth just because I grew up in the 90s and stuff. So it's Seinfeld. What is it a show of? It's a show about nothing. And you've written a paper on nothing, my friend. So why don't you tell us a little bit about that?
So the paper was called Nothingness, Qualified Existence and Membership Conditions. And it's about using typed existential quantifiers. They have a little superscript above them to denote the type of existence that they quantify. In my opinion, saying that nothingness exists is a little too strong because we're still stuck in an existential framework. We need to move beyond this existential framework towards a more general concept of isness. And this isness, whether or not there is something, does not strictly entail that it exists. And when we use the traditional existential quantifier, we mean that something exists, but there are other types of isness as well. And this would allow us to basically license discourse about more primordial forms of isness.
Can you give me an example of isness?
An example of isness. Well, so it depends on what sort of system you're privileging. In other words, what takes priority. So let's say that we're privileging historical events. Then isness would be something that's outside the scope of history, something that didn't instantiate itself and animate itself through physical being. So any sort of innate or underlying types that were that we could speculate upon. And there are also other things that can be privileged too. When we're talking about reality in the everyday sense, we're talking about physical reality and physical existence, in other words, basically history. But we can privilege, mathematical constructs. We can privilege other sorts of truths.
So was there anything in particular? Because I realize it's basically a paper about nothing, and I probably should have given a little bit more background on that before, because I had first noticed some of your work because I think you were talking about like GR or something like that within the Toe Discord community, and then you had joined us in the Theories of Nothing community as well. So I'm like, wait a second, this person looks a little familiar. Oh, they're one of those maths people. And don't get me wrong. I stand by math is hard. That's what Wolfram Alpha's for. But my big thing is I've spent a lot of time kind of going the ontology and stuff like that. A lot of folks talk about consciousness. What is this? What is this? And don't get me wrong, that's totally fine. My current niche, something that I never really saw coming, I actually kind of tried to deviate and avoid for particular reasons. But it's kind of like, let's run some computations. Let's see what's going on and stuff here. And I just found it very interesting. I think you were talking about, I don't know, planetary motion. I really don't know what you were talking about. I should have probably brought it up, but it sounds like you essentially were writing notation for you were notating how we could show that we could get nothing from something.
Yeah.
Okay. That's. I was trying to align. I'm like, no, something from nothing. But now it's like, how do we actually prove that nothingness is a thing? Because you're like, oh well, that's nothing. But when we say that, what do we actually mean? Because in common vernacular, there's nothing there. Or is it? Oh no, don't touch the cookie jar. There was 12 cookies in it. Now there's nothing there. Now there's probably really crumbs and stuff like that. So there's something. Okay, you clean it out. Okay, there's still some air there. Even if you do a vacuum, well, one, you could probably break the jar. But and this was brought to my attention by I think it was Professor Hoffenstelder. She was talking about something with, I think it was Professor Brian Greene was saying like, well, there's like 7 layers of nothing. I may be getting that attribution gone, but she ends up going. It's like, okay, well, there's nothing. There's just space. It's like, no, even Professor Keating, he's like, there's probably going to be a proton somewhere in there, probably like 420 electrons or something like that, or photons, CMB radiation. Okay, let's remove all those particles things okay, well, it's still kind of quantum fluctuations. What are that? Okay, let's remove that. Does mathematics still exist in that space? Delete the mathematics. Are there any engrams left? And when you actually start to go down, it's like, is that even nothing? Can we even picture nothing? And that's been a lot of different conversations that have been going on. I feel like it's coming at it from a different route, and I like that. So, you want to just bring up the paper?
Sure, you can.
Okay. So, yes,
It's quite short.
I'm totally ignoring the people in the chat. I am so. What did I just come back to? I just come back. Okay. Yes. And welcome, Whitechapel, and Shoutout, my internet mom. Yes, welcome everybody. Good to see you all. But okay, let me actually. Oh God, where was it? What did I do? So how's everyone else doing? How are you doing, Ryan?
I'm doing pretty good, thank you. A little anxious, to be honest, but
Wait. You're saying you're anxious by getting on a live stream, broadcast over the entire world on YouTube with some random dude that you met on the internet wearing sunglasses and a yellow level up shirt.
that's fair. It's quite a vibe.
I was gonna say, does that make it things better or worse?
It makes things better.
Cool. No, that's what I
Slightly.
try to go for, dude. That's the thing. It's like I try to be. I'm not smart enough to keep track of all of my lies. So I realized a long time ago, it's like, well, rather than like telling lies, what if I told the truth? I don't need to always tell the truth. I'm an oversharer because that creates awkward moments, which is literally, I think, what my Patreon says, creating awkward moments since like 2018, 2019, something like that. I basically am the same way, more or
Well,
less.
can I say something?
Shoot.
You oversharing is not awkward for me. It's fine. I mean, if that's what you're comfortable sharing. In my opinion, if you're oversharing, you're not the one being awkward. Whoever feels a certain personal way about it, that's their personal feeling. They're the ones who feel the awkwardness. So why does that make you the awkward one? I mean,
Oh no, go on.
you could both basically say that you're playing a role in creating that awkward situation. But at the end of the day, it's really only awkward for the one that is experiencing that.
I agree with Kylie. We need more hugs. That's the opinion of a dude on the internet. No, what I find is, number one, a lot of folks in general, and based upon my experience on the internet, may tend to be a wee bit awkward. Number two, I find when I actually share stories, might make some folks feel uncomfortable, but every once in a while, whether it's at a pub, whether it's literally just at the end of a live stream after everyone else left, it's like, dude, thank you so much for saying that, because I had the exact same experience. Whether it's like putting a Twinkie or one of those Swiss rolls in the freezer, letting it like get all cooled and everything, and it makes it so much tastier to eat, especially with a glass of milk. I apologize to my lactose intolerant friends, but you just try to be straight with people. But okay, do I have? Oh my god, all these different. Why is this so hard to? Wow, this. I've read some articles on this site, and it's totally learned me. It starts. Actually, I think you're. I think. I wonder. This may have been recommend. Actually, no. I read this, and then it was recommended to me anyway. So by the algorithm, I got an email, and I'm like, why does the title of this paper sound so familiar? I'm like, oh, I read that the other day. All right, so here we go. Nothingness, qualified existence, and membership conditions. Independent Journal of Math and Metaphysics. R.J. Buchanan. Rosebud, Oregon. R.J. Buchanan, 2000. Oh my God, I am so old. Wow. You were literally born in the new millennium.
Yeah.
God. So no, see, people like no. It's the younger generation that actually gives me hope. People like to say, "Oh, look at what the kids are doing nowadays," and I sit back and I'm just like, hasn't every generation said that?
Yeah,
Well, this time is different. Why? Because we're the ones saying it. Okay.
right. One of my favorite movies was Richard Linklater's Slacker from 1990, and that.
I'm trying. I feel like I get that confused with Office Space. What? Because which one of them was the one where it's like they're like, all right, we're gonna put a very very minuscule like transaction fee, like billions and billion trillions of a penny on every ATM transaction, and over time it will add up. They got the
I don't
decimal
know.
point wrong, and they charged a penny each time. People noticed immediately. I think that was Office Space, but
That sounds fun though.
no.
Or what?
That's why decimal points matter. It's also deep lore.
Yeah, so if you see right here, you basically see what I'm doing with the little element symbols, how they have these little superscripts.
Okay, hold on. Let
So
me
we have this theta element, and above the element symbol itself, you have a pi, which basically it could indicate a variety of things depending on the context. First of all, it could indicate that we're using polar coordinates, or that we're embedding a Euro element in a sort of transcendental stratum. Um,
Now,
uh,
did you? I noticed here because you have this funky E that I've seen before in other papers, and now what I noticed, you start having this backwards, more less funky E going on, and that's the quantifier for there exists, and then you have there exists star.
mhm.
Um, okay. Did you want to read through it? Do you want me to read through it for you?
You want to read through it? We can take turns, do a sort of popcorn reading.
All right, all right. This is good because I read this when I was very tired, and I'm like, it's following notation. It seems to be consistent. Do I know that? Have I checked? No. But okay. Preliminaries. Let our star of alpha be a representation of some generic idea, alpha, in a principally dash star space. This function may be written as alpha goes to
I
r, or how you're going to have to coach me on this because I'm actually going to learn here because I just speak words to the best of my knowledge. I'm not a professionally trained mathematician.
I would read this as alpha into alpha star in A by R.
Into alpha star.
Yeah, so
Say that one more time.
you're letting alpha be transformed by R into the star element in A.
Okay, so the arrow. No, this is great, dude. I'm learning mathematical notation as we go. This is fantastic. Okay, so
Yeah, and at
alpha,
the
and
top
then
you could just read that principally star space.
stars. I like that even better, dude. Because the Super Mario Brothers movie is out now. I remember, dude, Super Mario World. Oh God, that was like
Chris Chris
7
Pratt
years
was so
before
good
you
at
were
jumping
born,
on
dude. Oh God, I remember getting the
quiz.
Star Road in that, dude. It was so much fun. Those were the good old days.
I didn't get
Ah.
to see it, but I saw Chris
Oh,
Pratt.
I haven't seen it yet. No, it sounds fun. Okay. So it's written as H is transformed by R. Excuse me, alpha is transformed by R into alpha of star space, and is this large epsilon of A?
That's
Is
just
that
in. It means element of, but you could just read it in, so A star in A.
A star in A? Okay, or an element of A.
Yes, as an
So
element of, yeah.
okay, so that is an element. Okay, okay. Oh, this is great. Oh, the poor chat is like, what is going on? It's like, oh, Super Mario movies is a 10 out of 10 according to Uncompetitive. That's good,
Right.
dude. My big thing with the whole Super Mario Brothers movie was, hold on. I watched the original Super Mario Brothers movie. Thank God, not in the theater. It was a halfway decent sci-fi movie. It was not a good Mario movie.
I saw
It
that
was a
one.
It was a terrible Mario movie. The one thing they nailed was the Bomb. The Bomb was so cute and just did its thing and happened to mess up. I'm just like, because the thing is, Super Mario World would come out. It's like you could have done so much more. It just, I'm glad they actually. My big thing is, I told them on Twitter, I'm like, listen, if you can nail this, I will totally forgive you for that abomination you came out with so many years ago. Okay, we continue to our
Right.
scientific stuff and things, but okay.
But the graphics look good so far. That's
Oh
all.
yeah. Well,
The
my big
trailer
thing is
looked good.
they use the Super Mario's theme from the old cartoon back in the day, or the cartoon
Oh,
slash live action and everything.
it's the
It was like,
Super Mario Brothers Super Show. Hey,
yes,
paisanos.
yes. Oh my god! It's like I really didn't care about the. I mean, it was kind of funny and everything. It took up having to do animation was wicked expensive back in the day, but I'm just like I remember watching that. I'm like, it was a corny show, but at least it was within the Mario like world and everything like that. Oh yeah, and they used that song for the intro to Mario Brothers for one of their trailers, and I'm like, oh god, I'm getting the nostalgia vibes. Oh. Oh, I'm starting to feel something again, Ryan. It's a good thing. Okay. Where we allow A to be stationary realization of alpha. And we may write, this is, how do I say this?
Oh,
The
the realization of A.
the realization of A,
Yeah,
written as alpha transformed by R into, okay, I already said that. Okay.
that
Where R,
notation is also used for norms, which makes it semantically rich, but I wouldn't say that it should be read as norm A.
okay. No, well, that was one of the other reasons why this whole thing I kind of wanted to do was some of these things I had never seen before. So I'm just like, what is this notation? And like that's one of the things that effective about mathematics is there tends to be a lot less beard scratching, so to speak, in that it's like you're gonna get the right answer or you're not, or maybe you're gonna need another interpretation. It's kind of like computation. It's like if you have a thing set up and you run it and it computes, great. If it doesn't, why doesn't it? Maybe that's more interesting. Um, but just the definitions and everything, because we use standard human language, and that tends to be quite imprecise. Okay, where was it? R and star space understood. Throughout this paper, we were right. Okay, I just wanted to make sure it wasn't a mark on my computer. This is N, and what's that symbol?
It's just an N with the tilde above it, but
Right, N.
we'll read it as nothingness candidate when we see it.
Oh, okay, so that's how you're denoting nothingness. Okay,
Yeah,
to
a nothingness
signify.
candidate, not necessarily nothingness per se, but not
Uh,
necessarily a nothingness that's privileged in a certain regime. For instance, a real nothingness or a physical nothingness, but a candidate for what nothingness could be, depending on what we take as our priors.
I like this because it seems like you've actually attempted and may have actually successfully quantified a method for figuring out nothing. Because that's the thing. I remember this is a candidate because what I remember is a lot of folks will go out there and they'll make very strong assertions, and that's totally fine. I support the freedom of the streets to make strong assertions. Reality tends to catch up with you though, because you make the strong assertion. It's like, well, what happens if you just get asked one question and that thing comes out? What you're attempting to do is, all right, we're looking for the realm of nothingness, so to speak. Um, so I'm like, okay, that's something that's a lot more. I think people would be more willing to understand. If you're like, random equation that makes sense to me equals nothingness prime, people might have a problem.
Well, if I could say something here, I don't want to interrupt, but there was a lot of things that I didn't get a touch on or I didn't feel were very clearly explained by this paper right here, and I was planning on writing a sequel. But yeah, I was basically looking for. So I don't even want to use the word thing. I hesitate to use the word thing because that means that what we're talking about, we imagine that it's embodied in at least a sort of abstract space. So I'm talking about it, whatever isness that is nothing. What is that, and what type of isness is it? So there's the is of nothingness itself, which is the nothingness candidate, and then there's also the membership nothingness, which embeds it basically as a quasi-negated element in any sort of coherent scheme.
Can you say that at least one more time?
Yeah, certainly. So there is nothing is different than saying there is something that is nothing.
Okay.
Because when we say there is something that is nothing, we're taking something, quantifying it existentially, and then embedding it into a concept space. And when we embed it, we have a type of embedding that specifies why its existence is coherent in that space. But when we take the untyped embedding, we just have that there is nothing. And it's not embedded in anything. And we find out what we needed to embed it into. What would its type be if we were to embed it into something? And if we say nothingness doesn't exist, then what we do is we take the nothingness candidate and we take the type nothingness and we embed it into any system. We say it's validated both in its candidacy and in its embedding type. Because if it's not embedded, then it's instantiating the type of nothing, which is negation, which is not.
Did you prove nothingness by negation? or did you set this up in a way? Is this is why the paper was kind of interesting, because I'm listening. I'm okay. Formally, we could prove it potentially this way, but if you challenge that and you say that it is not possible, you're using something within type theory or something like that, or at least mathematical logic, to say, well, basically you prove it because now we can put it here. You've established this type.
Gotta plug my phone in. Yeah, it's a mix of type theory and intuitionistic logic, basically.
Did you just find a loophole for like nothing? Because that's
more specifically Martin Luft type theory, which is what Hot is built off of.
I mean, this would be fantastic. I mean, like, see, I love that, because you're like, all right, I'm going to attempt to take a first run at formalizing a way to define nothing. If this doesn't work, there's always this. And that's why it's like a lot of folks, like, they might be familiar with something. Actually, Professor Wolfram was just saying this a little bit earlier about like AI and everything like that. He's like, oh yeah, no, there will definitely be breakthroughs with AI and stuff, especially once it gets its full Wolfram superpowers and everything. Just because if it has a large language and knowledge from billions of websites and stuff on the internet, it might have knowledge in, let's say, I don't know, he was using an example, I think, like economics, physics, or chemistry, or something like that. It's like, well, there's a very rare particular phenomenon in like chemistry or physics or something, but also applies really well to these financial items or something like that, or an economic theory or something. And like, it's that cross pollination where I think that was the whole like thing for Dr. Eric Weinstein's geometric unity. It's like, here's something from his PhD thesis and stuff, happens to be something that is used in economics a lot of time. I think gauge theory and stuff like that.
And some guy wrote a response to Eric Weinstein's economics and gauge theory. He was very critical of it. I think it's an interesting program, and I think it's worth considering. I think it takes a little bit of schizophrenia to be human and to do the type of skilled abstraction that humans can do. And I think that AI at this point doesn't have it. It's very good at mechanical abstraction. For instance, if you define a class as a name, and then you define another class, and you say substitute this class for an item within this class. And if you have all sorts of things defined for how it should abstract and how it should relate things, then it becomes good at it. And people say that it's good at creativity because it introduces mutation, but it introduces on-level mutations at the level of the thing it's working with. It doesn't tend to schizo out a little bit and introduce some sort of abstraction elsewhere.
Well, it's a new type of thinking. That's the thing. And even if it's not a new type of thinking, it's a thinking that may have been thought along similar lines before, perhaps by somebody, but if it hadn't been communicated to other folks throughout history, or maybe if they wrote it down, that thing got thrown out and stuff like that, how long does humanity have to wait before we come across that again? Because I just base it upon history, and what you were just saying right there, Ryan. Basically, even Professor Wolfram said is the strength of AI is knowledge of breadth. But basically, as you were iterating, it doesn't currently have that depth that humanity can have and everything there. So it's more like has a large knowledge base, but how is it? Does it have the ability of humans to abstract in different ways, to do those so-called Duncan experiments? Or if this was to be the case, what way may we actually try to deduce from that? Welcome, Jax. Good to see you. Oh, and Kotov.
Hi, Jax.
So to respond here to your email, that whole 2 strands and 4 strands thing, I don't know, a 2 and a 4. Now, if we were to make that, let's say, a 6, is there anything we know of within our realm of persistence that has a 1/3, a 1/3, and a 2/3 relationship that might be important? That's all. Just speculation on my part, just speculation in response to his email. Deep lore, my friends. There's deep lore going on the internet. Okay. So why don't we... Let's go into, because you said you actually had some more stuff. How would you like to describe this? Like, how about this? I'll give you the floor. Give me the elevator pitch, like 5 minutes, a little more time if you need. What are you trying to communicate?
What am I trying to communicate? Geez, I think 5 minutes might even be a long time for an elevator pitch, unless we're going up to the 200th floor. But basically, what I'm trying to communicate here is that nothingness is a very loaded word. When you ask what is nothingness and what would it look like, it's full of assumptions that are encoded into the way that we talk about things that are, and processes of being and becoming. That's basically what I'm trying to communicate here. If you have any questions, I can answer them, but I'm not really good at sharing my ideas in this way. Hold on. So our symbols in classical logic are very strong, and there's been a lot of attempts at trying to revise this sort of logic. And a lot of these take the forms of many-valued logic. For instance, Kleene and his star operations and his logic. But there's also been...
Sorry, go.
Oh, you're fine. So it's basically saying the system is broken, so let's add more of the same thing, because we have 2 logical connectives, and some people want more. But then there's also these more category theoretic and homotopy type theoretic approaches that attempt to deconstruct the idea of equivalence, and they define explicit equivalences and weaker forms of equivalences. For instance, math for most of history just used 2 horizontal lines, equals, and that just meant equals. And now we have lines with increasing numbers of squiggles over them. Like, eventually we're going to start seeing
that. I Wolfram Alpha once I'm like, what the heck does this even mean? It's giving me like the output script. I'm like, why are there 3 lines? Is it super equals or? I don't even know. I'm sorry, I sidetracked you. Go on.
Oh, you're fine. So it's really confusing because the language that we use, depending on which program we're working in, it'll mean something that means something completely different in another language. For instance, the equal sign with the squiggle over it is sometimes denoted by 1 line at the bottom with 2 squiggles over it, which is homotopic. Some people use the word homeomorphic when they mean homotopic, and then other people will use the word isomorphic for the strongest version, and then they use the word homomorphic only to mean a weaker version of isomorphism.
Are you saying people within the mathematics community don't have a full agreement on all the notation?
They would like you to think that they do, but a lot of it is
hand waving. It sounds like. Okay.
There is some hand waving, and I would say it's more of suggestiveness, because mathematicians are very suggestive, and trying to imply certain things with their notation without explicitly stating them.
I
And a
mean,
lot
that
of the
sounds like
times they'll
every other
even,
human being in the world.
yeah, I mean, we're all
A
like that.
mathematician's a human. We've proven it.
So, yeah, there's a lot of abusive notation that goes on, but then there's also a lot of what is not really abusive notation that's just a very subtle subconscious alteration of the way that we perceive certain functions, or if you're already familiar with a certain notation, but they're secretly using it in a different context, then you'll use the pre-built-in association, and that's one of the ways that the mind will create links between different areas
It's like
and
we
sort of build.
usually. Oh god, no! I remember this sort of thing called like chunking theory. Like you'll have like a little chunk in order to like rather than memorize every single word. Like what was the general concept? What did I take? I just call it like it's like a mimetic equivalence. Like I rip off a lot of stuff I learned from physics and just like throw meme in front of it, like mimetic. Just because
Yeah,
the crazy thing is, you seem to be able to make a lot of maps. Like I feel like there are actual mimetic tensors and stuff like that. Like you were just saying, they're not saying it directly, but they're thoroughly implying that.
absolutely.
So you can make those connections. Go on.
Absolutely, and I would like to add to what you were just saying there, memes. I don't know, I've never heard of chunking theory. That's a good way of putting it. But what I have heard is cognitive shortcuts. They say that humans are cognitive misers, and so they prefer to take in the least amount of information that's going to get us the most amount of results. For instance, let us say that we're at a pub, and it's a sports bar. And I don't know anything about sports, but I know that we're, in Philadelphia, and I say to some guy, "Go Eagles" or something like that, and then I know he's passionate about sports, and he'll pick up on that, and so that is basically an entrance into a valid conversation. And then I could begin learning some statistics about the Eagles, maybe if he talks to me about them, and I could relay
Be
those to
wary.
other
There might be
people.
he might be a Flyers fan. That's the thing. Uh,
I would tell him to
yeah,
get out.
Pennsylvania. They got two teams, I think.
Oh, sure. See, I truly do know nothing about sports. Um,
No. That makes a lot of sense. No, dude, that makes so much
look,
sense. But I'm just saying that there's that one caveat in that particular instance.
oh yeah.
Yeah. No,
But
hey, I just tell you, hey, go Pats. Continue, finish your thoughts, sir.
I think that I had finished my thought there. I originally had this idea called museum theory, and it was built out of this idea of cognitive prisms. Basically, there's three different ways that people build connections in their mind to create these cognitive shortcuts. First of all, there's relata, the number of things you're relating a concept to. And then we have visits, the number of times that the concept is basically accessed in your mind. The relata would basically be the number of other things that have the same meta tag. And then you have a third thing, which is the number of exhibits that you visited with regard to this one topic. So the properties are exhibited through verb type usage, but then there also exists as exhibits that can be referenced like a museum. And so we create these prisms with three dimensions, basically. And when my thinking became more complex, I had to put a stall on this idea and stop thinking about it. But basically, the best, most perfect conceptions in a Platonic sense would be the ones where all the dimensions were equal. But then I had to start thinking about refractivity and reflectance and all these other optical properties that the prisms might have. And I don't think I have a strong enough grasp on groups yet to be able to put this in a really rigorous way.
I mean, you're only trying to explain reality itself. That's all. But my thing is, I love it. I'm gonna have to get you and Brandon on at some point because this is the big thing. It's like I tend to agree with Professor Wolferman that I think we're all talking about more or less the same thing. We're kind of like all right in a sense, in that okay, maybe there's some details here and everything, but just your use of a particular type of type theory and stuff like that. It's like if this did work, it kind of reminds me of, oh, what was it? It was a Veritasium video from a while back. It's mathematical theorem. It's like, all right, you have a ball. According to some mathematical tricks per se, you can take that ball and turn it into like 4 other balls. So
Yeah,
like
yeah,
something
the
like that, right?
Banach-Tarski paradox.
Yes, yes, with the Barnard-Toski paradox. It's like, how does this even make sense? But if you go through and you're going through, like, it says it can do it apparently, and like, wait a second, a lot of stuff within math seems to represent like reality. What the heck if that was what would that even mean? I mean, I have my own speculation. I may or may not have done a video on it. That's a story from another time. But I love how like somebody like a young person like yourself, you're studying mathematics and everything, and power to you, man. But you're learning these things, and now we have the internet because like when I was still going to school, like many millions of years ago or something, like we'd have these libraries when we'd have a computer, but you'd look up, but then you need to go by the Dewey Decimal System. And the Dewey Decimal System, oh my God, I'm like, why? We have computers. Why does it need to be? I'm starting to have respect for the Dewey Decimal System in my later years. I feel it was made by a whole bunch of engineers from back in the day. They're like, all right, this makes sense from a category theory perspective, perhaps. But I was young and brash. I'm just like, just show me where the dang thing is. But
Yeah.
the ability to have access to the internet, to be even okay, just even Wikipedia just as an initial point, or looking out at Math World, wherever it is, finding a topic, maybe finding some actual articles, citations, some perhaps a little more formalized, if you would, if it's available, and you can start studying and be like, oh, somebody discovered this back in the day. That's cool. Here's this thing. Well, here's this potential situation. Where might this be useful other than this random obscure thing? I don't know. What happens if we're trying to prove that there's a potential nothing? Well, if you try to negate that, you just instantiated it as a type. Therefore, nothing is a thing. And it's like, what? I never even considered that part. And I find that's fascinating. So I feel like those little tips and tricks that we find, if we can find them within different
So,
scientific communities, because somebody like your knowledge, you know the math and stuff like this. I'm a dude on the internet that tries to talk to a lot of smart people. And the one benefit of talking to a lot of smart and interesting people is I learn things. And even if I learn something, maybe it's something that would bored me. Like I remember Professor Wolfram for like months, he was talking about Turing machines and Turing machines. I'm sitting there like, oh God, get back to the physics stuff. I don't care about the Turing machine. Now I sit back and I listen to some of those old things. I'm like, oh my God, this is so important.
I
Because of
know
us.
some of the things that you never thought you'd care about one time, and then all of a sudden you take that shortcut to get there, and you realize how close it really is to all the other places in your mind. It's like, wow, I'm gonna have
Not
fun
even my
taking this
mind.
walk.
Well,
And
when you happen across certain circumstances and you hear someone describing a story and you look into the story a little more, like, okay, and it's like you start investigating something for another reason, and then you're looking, and then you revisit it like months later after you learn more stuff, and you're like, wait a second, no, that can't possibly be the case. And then you look further, and you're like, this might explain a lot. It makes I won't get into my conjectures here. There are videos for that, which I need to actually list an actual real playlist so people that are interested can kind of, because I'm realizing I'm like, somebody mentioned something about, oh, a video that so and so did about this. I'm like, I don't even think that person know that I interviewed Stephen Wolfram on a live stream just because it's back like several weeks now on a live stream. I should probably make it one of the front videos just because I should try to establish clout now.
I can't believe you got Stephen Wolfram. That's big, man. That's awesome. I'm proud of you, for real.
I I sent him an email.
That's it. That's all it took.
I sent him an email like 7 months later because he gets like 600 emails a day.
Yeah.
It To be fair, a lot of it is probably because he actually recognized it. Basically, kind of behind the scenes, it's like it's like, hey, so and so, blah, blah. You may recognize me by my YouTube handle, the memes of the show. Because he said he's like, I get 600 emails a day. It's like he reads through it. Like if you send a massive wall of text to somebody, and especially if they're a fairly prominent person that gets like a lot, like Dr. Eric Weinstein, Professor Brian Keating, someone like that. They get all these emails and stuff like that. And if you send a mass, it's like, are they really going to read that all? Maybe they do. Maybe they do. I'm terrible at keeping up enough stuff with myself, and I'm just a dude on the internet that works at a warehouse. So I'm just like, send a brief email. You may recognize me by my username, and apparently got reached out to. It's like, okay, yeah, no, oh, yeah, Steven would love to do a live stream and stuff like that. It's like, I'm like, oh, okay, that's cool. It's like, you don't seem to understand. The only reason we're having this conversation right now is because he recognized your user handle, your YouTube user handle. Because I attend, he does a lot of weekly live streams. So I'll pop in usually for like the science and technology ones and different things like that. If he's doing thermodynamics or NKS, I'll be there. I'll ask questions. He's answered some of my questions. I've clipped some of it. Some of my greatest viewed videos because, well, it's about relevant topics that I think are important that maybe folks should know about. But yeah, no, I reached out to him. We set something up and had the pleasure of talking with the gentleman. He's the exact same as he is. It's one of those things where if you spend enough time listening to somebody on the internet, if you have a large enough sample size, maybe Stephen Wolfram will go up on my live stream and start doing backflips or something like that. It's probably not the case. Probably just going to talk about, just give him a topic and he's going to go. That's what happened. But no, I like the combining of different folks that know different things and having them maybe talk to each other. That's why I suggested maybe we'll reach out over the next few weeks and maybe we'll brand him on, because he kind of did something very similar after like years and years of introspection and doing graphic design and stuff like that. He basically has these categories, and it's basically like, okay, here are these characteristics. And I feel like somebody with maybe more of a mathematical constructive background, maybe we can put our noggins together and actually start to conceptualize something that, because I had some of my ideas. I'm working on some other things now, but I'd like to see humanity move forward and actually like do useful things.
I would love to have a conversation with Brandon. I mean, I've heard him speak before. He's a very smart man. I would like to talk to him. That would be cool.
He has a very deep ASMR voice. Like I could listen to it all day long.
He does.
But he's so concise. He's so concise. Most of my interviews with him were like less than an hour. I'm like, I can travel on forever. But I asked him a question and like 2 sentences, it's answered. I'm like, oh my God, I can spend 15 minutes not even answering a question before I get around to answering it. But I do like the little back and forth, as well as we have Harry from the Wolfram physics community as well. It's yes. well, okay. You want some deep lore on in the Wolfram realm? I've been listening to the Wolfram Institute's live streams because they set up the Wolfram Institute. They have a YouTube channel right now. Very few people are there. I'll pop in there, and actually, Carlos, shout out to Carlos. He answered one of my questions, and James, one of like the head of like the Wolfram Institute now, was like, that may be the best answer we've had on any of these live streams to anything. And Carlos responds to the chat. He's like, that's a good question. Like, all I did was, anyone else find it funny that in our reality, the imaginary unit seems to describe it really well? And he kind of just went off. He's like, no, well, we call it imaginary, so it might seem silly, but it's just describing complex numbers. And we've had like minus numbers for a while. So it is logical. But I feel like just the sheer irony that to describe like the world as we know it using I or the imaginary unit seems to do it really well. I just, this is the humor within life that like, these are the little things that like, it gives me a little joy to point it out. It's like, we're talking about these serious things, the building blocks of reality, potentially proving nothing exists. And it's like, these seem like paradoxes and everything. But I feel like if we can find humor in it, it'll at least give us a more upbeat attitude.
I think that recently mathematicians have started to get a little more sarcastic. Like we've moved on from the complex numbers. I mean, they're definitely still used, but they're not the most interesting thing or the most out there thing anymore. Now it's the super real numbers. They're like super totally real, dude.
Right. Are the super real numbers a thing?
The super real numbers are a thing, and they were invented by Hugh Wooden, who was a researcher in large cardinals. and now they're being applied to quantum mechanics. Go on.
I'm looking this up right now. Oh my god, it's literally spelled super real.
Yeah, all one word.
Literally all one word. It's, oh my god. So this was invented by a gentleman that, just based upon abstract notions of other folks, he was basically contributed strongly to the field of mathematics within the past probably century. And since he has that community clout, he's just like, here's something that might be useful. I'm just gonna call it the super real numbers, just for like either sarcasm or fun's sake. I mean, physicists have been doing this for a long time. It's like, what do we have as our model of particle physics? Well, we have the standard model.
Yeah.
Okay. What is, and it's like, even
then we have WIMPs and SIMPs.
Oh my god.
Weakly and strongly interacting massive particles.
Yes. That's. I'm like, the trolling within the physics community. The
P
Schrodinger is. Oh my god! I just made that connection right now. That's so beautiful. See, I always like the whole turtles and everything, because apparently with some black hole coordinate systems, it was called the Tortuga point. And
what?
a notation yes, I did a video on this. Turtle coordinates. But basically, yes, they call it the Tortuga point. And the notation, I was trying to read that. I'm like looking at it, I'm like, is that a turtle shell? It looks like they used a turtle shell for their notation. They're playing off the turtles all the way down meme.
That's so cool. If you could send this to me afterwards, that would be very cool. I would like to watch this.
Yes. But we must remember, it is yet to be proven that
world exists on the top of a giant turtle.
It made me so happy that I could play that at the end of the live stream with Stephen
cut off
from
a little
there.
short.
I get him to laugh at that. It's just like, all right. Wait. We got a laugh from Professor Wolf. All right, the show's over. But okay. You said the length of Ryan's thing is in the doobly-doo below. Let's see.
If you could show back to that and scroll down a little bit, that would be cool.
Okay, let's go back.
Sorry.
Oh no. I realized I was trying to figure. Okay, where am I going? How far down? Oh wait, I went all the way down. Yeah. There we go.
It depends if you wanted to give it a full sweep through or if you just wanted to skim through. It's pretty short though.
Let's keep going. You want to?
Okay.
Pick it up? I think we're down here at E is a type monomorphism. Is it okay? All right. So blah blah blah. Okay, we will let E, which is basically the what were we saying that was again?
That's the generic existence, untyped existence symbol, the one with the little dot above it.
Okay, so we're be a dot typed monomorphism of some kernel Q. Is that pronounced? Okay, is that
Q.
Still Q dot? Okay, into an R space, and that is not representative of nothing, or
you fill in the blank. So the blank could be your nothingness candidate, or it could not be.
Okay. My big thing is I would just make sure there's full notation and everything. I'm sure this is all there, but just my initial critique. Simply put, there's an embedding of some relatum into a codomain, which it constitutes an appreciable and observable object. For instance, writing an e to the f of c sub k divided by p allows one to specify that there's a p-adic element of a non-Archimedean field while sparing one the burden of writing out all such technical details. Conceivably, any sort of type membership condition must be employed, although in practice only some are amenable to us. Some examples include the following. That is 0 of existence pi, and basically you have your, okay, so, and that's tau e of that. Okay. So what are these?
Yeah, that's mean? The fuzzy. That's basically tau is a truth value. F means that it's fuzzy, and then sets is the category. So that's basically fuzzy truth values within a set.
You're using fuzzy sets?
Yeah.
That's a mathematical thing?
That's a thing.
Groovy.
Yeah, it
What?
was basically an alternative to 0, 1 truth values, was to have graded truth values.
I
That's
think a
not
lot of
used here. That's just as an example of what we could use the typed membership for, is we could use the fuzzy type.
okay. Well, I like fuzzy things. All right. And what is the first
Mm.
thing here? This is basically setting up the boundaries.
That's polar coordinates, or you could use it for transcendental liftings. I think polar coordinates are a more direct application. They make more sense. And then the last one is differentiable manifolds, partially differentiable manifolds, and
Hmm.
D represents the boundary of the manifold.
Cool. All right. This is very mathy and stuff like this. God, I need to catch up on my math.
Thanks. I
Okay.
tried.
Okay. And then you have it formed as writing alpha e to the f c sub k and p. So what we're saying is, okay, can you tell me what a p-adic element and a non-Archimedean field is? Or what is a p-adic element? Start with that.
A p-adic number, or either an element of an adic space. So when we use the decimal system, we're using a 10-adic system, but a p-adic system, basically, instead of putting zeros on the right-hand side to let us know that the number is bigger, we'll put them on the left-hand side. And instead of just counting like 1, 2, 3, 4, whatever, we'll pick a prime number, and then for p-adic, whatever prime we picked, we change the p to that number, so we could have 2-adic, 3-adic, 5-adic, etc. And then whatever number you have to raise that prime number to the power to, in order to divide out the first number, that's the p-adic valuation of the number. And then, yeah.
Cool. All right. What's an Archimedean field? I feel like I looked this up before in Math World, but I don't know.
So I forget how to describe this one right off the top of my head, basically. But if you look into perfectoid spaces and a lot of the universal type Muller theory and stuff that they're doing, they're using non-Archimedean fields, which is basically a field where the triangle inequality holds and one or two other conditions.
Okay. I just looked it up real quick. It brings up Archimedean property and abstract algebra and analysis. The Archimedean property, named after the ancient Greek mathematician, is a property held by some algebraic structures such as ordered or normed groups and fields. Properly, typically construed states that are given two positive numbers. Okay, so it has some properties there. So you're saying we're talking about a non-Archimedean field.
Oh, okay, yeah. So a non-Archimedean field, basically a normal field is Archimedean, which means that there's a field axiom that it satisfies, and there's two of these. The first one is that for every non-zero number, there is some number k that you can select, so that you can divide the first by the second and get the inverse. So
it's a method of manipulation.
It's a method of manipulation, basically. So, like, if I say that I have 1 and 5, so if I have the number 5, that's 5 to the power of 1. 5 to the power of -1 would be 1 divided by 5, so I would take one number and divide it by the second to get its inverse. And fields that have this property and one other special property are called Archimedean. The non-Archimedean field just generalizes a bit further so that we don't have to use these strict conditions.
Cool. You know what? Oh, this is great. This is great. Okay. So we continue. So basically, it sounds like you're setting up that, okay, normally we define things by this. This has got to be something that is not what we currently know. So that logically makes sense to me. All right.
Yeah, do you see your name there at the bottom?
I do. All right. I'll take. Hey, I got a citation. The funny thing is, Professor Sean Carroll at one point he's written papers and stuff like that. He's like, well, if some young person ends up using this video as inspiration and they come up with something useful, maybe they'll cite this video. And he said it in a slightly joking way, but I'm like, I think that's going to be how things are going to be done, especially with like AI and stuff. It's like now it's like, well, did you really write this? Did the AI write a lot of this for you? Did you go by and trim it and stuff like that? I mean, I realize that deepfakes and stuff like that are gonna be a lot of other stuff, but I'm like, well, if cite whatever gave you the inspiration, stuff like that. Isn't that the whole point? But just my personal opinion. All right.
Yeah. A lot of people like to cite papers so that they can include an exact sentence line, an exact definition. I'm not really that kind of a person. And I think as we move towards the future, and, I hate to make a statement like this because it's just so cliche sounding, but time's speeding up, and so I think things are definitely going to be changing here.
It's no, we're on the cusp of something. We're just gonna say great. Great can go both ways.
Right.
Learned that from Harry Potter. But what was it? But what what did they say? I totally forgot. Okay. All right, we'll just continue. Our primary strategy for delineating our narrative will be to use these type memberships to inaugurate a sort of ramified existentialism. I like it. The crux of the subject matter involves some mild contentions with the use of terms exists and its conflation with the existential quantification symbol used in a predicate logic. In order to further this contemplation, we will weaken the quantifier E. Okay, so we're all right. We're turning around. There exists E star space. The form we written as E square box.
Yeah, E square.
All right, E square, in order to make explicit the assumption of the classical quantifier is strong, so denotes necessary existence, i.e., there necessarily exists.
I would prefer if people read it as E strict, though.
E what?
E strict, just because it's the strict one, but there's no way of, when you're reading it, you didn't know that. There's no way of knowing that before you read it. So
no, dude, I feel like this might also scare a lot of people off from like reading papers and like learning more. Actually, I remember what I was saying. To be fair, I was listening to one of the Wolfram live CEO streams. And at one point, it's like, well, we have these bibliographic things where we're able to do this stuff. He's like, Professor Wolfram was like, do people still use citation and stuff like that? It's like, do they not just use links anymore? Like, isn't this the new thing? Like, if you're going to link to a paper on the archive, like, do you really need all that other data, or do they just need the link to see where it is? I mean, you can have both, but I'm just like, oh my god, the dude that created Mathematica, totally vibing with me. I'm biased to that too.
Yeah. Well, I completely agree with that. I think that a lot of people were just raised, including myself, thinking that there's just something more right or correct about using traditional citations, but it's just an added burden.
Well, before, that's what you had to do back in the day, to actually like show that you had a source, because we didn't have the internet with like electronic like encyclopedias. You needed to cite Britannica chapter 34 from like 1996 and stuff like that. Oh god. The hard old days. All right.
But it would be kind of funny if somebody just left like a link to the Bible as a citation or something. It's like the other extreme, not citing any pages or anything.
Oh god, that just leaves it up to interpretation there. People's minds will find all these connections and shortcuts. All right. The reasoning for such a notation is twofold. Firstly, there is to ease the conflation of the phase there exists an element A, where it is really meant there is an abstract element A. This is because in pragmatic and everyday language, the existence of a material or immaterial thing is taken to mean that it is only a physical or mental ground, which instantiates the noted item in ordinary reality. This is to say, there is an abstract quasi-Platonic ideal, Q, which is unqualified, and there exists an accessible representation, R star space, to Q raised, whose objective characteristics qualify as existence for Q. Secondly, by weakening the traditional existential quantifier, one exhibits a whole host of tactics for reasoning about, namely, para-consistent logic and possible worlds. All right, I love some of the phrasing here. Existential quantifier, or quantitating existentiality. Love it. All right, there. citations there. All right. So, choice of fundamentals. I must include this section because it's related to a recent discussion which many of my interlocutors profess to believe that language is fundamental. I love how you have it in like Wolfram language style notation there. That's beautiful. Simultaneously with nothingness does not exist. Let W of N be a word which describes the concept of nothingness in a language, L. Because language is taken to be fundamental, we can simply write N existence to the W or to the word to L.
Yeah.
Oh my God, I'm getting the biblical vibes now. This is crazy. Where N is of the same kind of all other objects which are primarily constituted by language. We have the following equivalence. All right, so that there does not exist of a word was that times T to the N. Did you read this?
So there is an N term that's T, that's N with the type T, or term with the type N, and the other side of this is basically what it's saying is that the existence of all words in a language in which they are valid is taken to be fundamentally equal. Okay. So if nothingness does not exist in language, then so do none of the other words. That's the N is a term which we could take as our nothingness candidate, or a term that describes nothingness, and then N prime is just any other word that's not that. And EW means that there exists as a word. T just means a term for N, basically, is how you could read that. So by a term for N, I mean a term for nothingness.
Okay, so what you're saying is, if there's no language, then we may achieve nothing?
What I'm saying here is that if you make the claim that nothingness does not exist, and you make the simultaneous claim that language is fundamental, then the existence of nothingness is the exact same thing as its existence within the language as a valid term. And so if there are any other valid terms...
And that's how you get to
Yeah, you would have to get nothingness by erasing the whole language, because if you take the word nothing out, you would have to take everything else out too. And so just the fact that there is any word that's valid means that in this sense, nothingness is valid, at least in a linguistic sense.
This is fascinating. Okay, that's... I see what you said there for two distinct terms, N and N prime. And then N does not quite squiggle 3 lines with a cross through equal N prime.
N not homologous with N prime.
Okay. This is to say the existence of a nothingness term is taken to be identical to the existence of all of the terms of the same type. Here, of the same type means that any term, i.e. hot dog, dung beetle, feeble, incandescent, etc., are all enshrined as bedrock expressions. Our expressions are taken to be categorically real and ontologically indistinguishable from one another. One may make the argument that they are not that I think you might want to change that to they.
Yeah, sorry.
Okay. No worries. It's
I mean, thank you.
I don't know. Is this peer review? Is this a peer review right now? I'm cited in the thing, so I'm like, no, dude, I want to help people and stuff like that, and learn at the same time. Where was it? They are not indistinguishable, but then one is liable to put for I think it should be liable to put. I made check spelling. To put forth
that's proper.
Okay. Yeah, I'm probably just it just looks weird to me. I say it all the time, but a presentability in such a way that accounts for the non-existence of the canonical fundamentals. To say one must justify that not existence of the word of T of K transforms to nothingness prime of K, which is back and forth compatible with... Okay, I'm reading this wrong.
Can I read this?
Yes. Okay, this is your work, my dude.
Okay, so the existence as a word of a term for K implying the fact that implies the strong existence of K. In other words, the regular existence that we use, the material or psychological existence. So someone has to justify that the existence of a term for K means that there is an existence of K, and that this implication does not mean that there exists really a nothingness candidate. That's the thing that needs to be justified here by somebody who takes the view established above.
So, Harry is asking, so basically there's no way around existence.
There is no way around isness, and there's no way around existence if you take isness to mean existence, which most people do.
I like how you specify there. And as far as I see, and then again, maybe folks will want more rigor because we're only just talking about like metaphysics of existence. But this is
if we weaken the existential quantifier, then there becomes no way around it. But if we treat it as a strong quantifier, then we can find ways around it, and that's when nothingness exists, basically.
So we've got those transformations, and then so it needs to preserve itself.
That the strong existence of K.
Okay. So this is a strong existence. Okay. So we're
otherwise just known as existence, but strong existence so that you know that it's not the same thing as isness.
Okay.
So we have to keep reminding ourselves that this is strong. It's not just normal existence. This is what we mean by regular existence right here, but it is stronger than other senses of the word.
So and then there would be the difference between that and what we actually take as an absolute quantifier. Is that what you're saying?
Well, what?
Was there something stronger than strong?
No, there is nothing stronger than strong. If you were to say that something strongly exists, it's the same thing as saying that it's strongly a member of something. So if you say that something strongly exists and it's in a member of something that strongly exists, that would technically be stronger, but not really. The strong existence is strong. But
does it give a categorical membership? Does it give it another identity when it's strong? Is that what I'm trying to get away?
Yes.
Okay. Cool. I remember I spoke with Jonathan Gorod a little bit there, and I was still trying. All I got away from kind of the general category thing, or no, maybe not category theory, it was something else. I'm like, okay, so we got the stuff, and then the way it's defined within whatever category is, it does or has a thing. So that's why and again, there'll be more specifics there, but if I can at least chunk it in my mind as, all right, there's stuff doing a thing, it has a very particular thing for its membership within this particular group, its category and stuff like that.
Yeah, but normally when we say that something exists, we already are saying that it strongly exists. We're already saying that it is categorified.
Well, that's the thing, and it's one of the less used things, because it's like, okay, well, how do we actually apply it? Well, we apply it to a lot of things, but what does that actually mean? So
I don't know how it could be applied yet. I think in the future that following this line of thinking could help with dark matter, but I'm not sure.
I personally, I think if we could solve for category theory, then we might actually have AGI. Just an opinion. But okay, so we encounter the annoyances of E sub W or E script W in terms of has one devoid themselves of any meaningful distinction between weakly admissible primitives and their strongly inadmissible representations. Okay, how about this? Rather than me butchering all your notation, why don't you just kind of give us, what are you communicating here?
So what I'm communicating here is that if there's a representation of something, then that means that the star space that it's represented in, or the type of space that it's represented in, is basically the same as the type of its existential quantification. But if we define I'm sorry. I'm really not doing a good job here.
Oh, no worries. No, how about this? How about this? What is the paradox? Because you were saying that there was, I think, a paradox that. Okay, the axiom presentation. What are you? What's the communication goal here? Between just anything here, like what do you want to folks know about these transformations and these back and forths?
What I want people to know is that basically, it's not clear to me, and that's kind of embarrassing. But weakly admissible primitives and their strongly inadmissible representation. So basically, nothing. It's strongly inadmissible.
Cool.
It's strongly inadmissible, but the primitive representing nothing is weakly admissible. But because admission is equated with representability in the classical sense, then we say that if something exists, then there exists a representation of it. And so we're saying that the types of representation are basically the same thing as the types of existence. And then this creates a sort of paradox because nothingness is weakly admissible. And so basically by saying that it's inadmissible, we're creating a type of nothingness, and we're admitting the non-existence of it.
And that's
which is
another loop
paradoxical.
there. Okay. So, well, we're gonna skip down a little bit because I think I'm getting a bit of your drive there. Okay, so let's discuss the absence of things. It's worthwhile to exercise to consider whether or not nothing is identical to its sibling term, no things. It is easy enough to accept such a proposition. For instance, if I were to tell you that there was nothing in the fridge, it'd be understood that the fridge is empty. In the case, i.e., there are no things in the fridge. However, crucially, nothing is tacitly typed in a way that no things is not. For instance, if one says there is nothing on TV is remarkably different than declaring there are truly no things on the television screen. Rather, is an indication that those things which may or may not be on the screen do not qualify as the type of things I'd like to watch. Two intermediate obvious choices for a nothingness candidate. All right, we get n equals r to the n equals, oh, look.
The,
Oh, I got the no.
the representation of a nothingness element or an n element, I don't want to say it's a nothingness element because we haven't even promoted it to the level of a nothingness candidate yet, but the representation of an n being equivalent to nothingness embedded as the empty set. And then for the next one, we have that the nothingness candidate consists of the closure of two elements inside the empty set. And so the fact that there are two elements inside the empty set and that these elements are locally appreciable and also further distinct means that the empty set contains your elements, or in other words, further unquantified, unramified, untyped things inside of it.
Huh.
And so, and then the first one, if you go on, if you would.
Yeah.
Okay, yeah. Thank you.
All right. So here we go. If we accept one, then by default,
nothingness is the empty set is one. Yeah, just a reminder.
Okay, nothingness is the empty set. And then defined as the tower of coexistent null classes, i.e., nothingness all the way down. This would be likened to von Neumann algebra, although it is unknown whether von Neumann would adopt the view of nothingness. The second option is a bit more interesting that we could be forced to adopt. That's supposed to be
your elements.
Your elements. I feel like I may have looked that word up. In order to model our candidate nothingness, a concept which surely does not exist in a standard well-founded set theory, where it calls for alpha of weird equals u. The a equals alpha to the a is the set of a. What's this funky symbol here?
Subset or proper subset. Subset or equal to.
Subset or equal to. Okay. Let's rewrite the expression. Okay, so we've got Translate what we're saying.
It says it right afterwards. You'll get a pretty direct translation.
Cool. Here's the left-hand side. The inequality represents the truth value of some generic n object, whereas the right-hand side indicates that it does not correspond to the existence or non-existence of a distinct object n prime. With
there's a lot of typos in here, and I'm honestly embarrassed.
No worries, man. No worries, man. I mean, this is the first thing you've ever put up there?
Basically.
Okay, there you go.
I didn't start posting things until the last couple of months, so.
Oh, good. You published more things than I have. Stakes inside an extended L complex plus. The L plus is a total statement of the quantifiability or sub-object classification, if you'd like, of any object S is independent of the isness of any object in the category of things. I like that. All right. That R plus is about equal to existence, meaning there's an item-free representation of some generic specified element, such as existence is unqualified, allows for the failure of an element to satisfy a criterion, which would prove it's our existence. In a regular universe is not sufficient to prove that a non-representable element, your element, exists in the sense of R plus and visualization. All right. So we make our assumptions here for our crazy notation here that may actually prove that nothingness is a thing. X is granular, so you had mentioned that before. Basically, rather than using our strict thing, all right, we're assuming some gradient here, i.e. X is the least sub-object for a maximally inaccessible category. All right. Existence is unqualified, and existence back to existence of infinity, and then that looks like a gamma?
It's a product symbol.
Product symbol.
The infinite star product of the existence of ...
Okay. Take the following phrase. There are no pencils. Gone.
The ... would be substituted for a composition of various different types of just various different
I feel
types.
like the ... or yada 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 would have.
Yada yada yada, yeah.
Okay.
Yeah.
Take the
blah,
following
blah, blah.
phrase. There are no yes, exactly. Blah blah blah. There are no pencils. This phrase does not refer to the positive position that there are some fictional pencils which do not exist, but rather is a proclamation which is supposedly negates the existence of some conceptual pencils that would exist, or rather, it is a statement that the conditions for generating something akin to strong existence in a weaker, incomparably type sphere of isness does not actualize itself in a space with stricter or differing conditions, which would be called existence. There are formal representation by the tau equation there, setting it equal to 0, where P represents a pencil. S to the K is a k-dimensional sphere. And then this is, oh God, what is that? I don't know notation.
I would just say weird. DSK.
Oh, I keep getting it wrong. I keep on seeing a small big A or a big small A. Oh, I get confused on Wolfram Alpha because I saw that I was typing in the constant wrong. I thought it was something else.
But you're good.
Okay. All right. DSK. Its boundary. That was the fuzzy truth value. Concept this as the absence of the pencil is nothingness, or at very least nothing. Consider. Oh, we've got zeta in there. We've got not existence of zeta. I like that. All right. Now may take
just keep going.
One may take n to be an abstract, your element, and some zeta, some pencil. It is not possessed in an infinite dimensional slice of, say, my bedroom. It does not hold that because the underlying ideal, i.e., my fictional pencil, is not represented by the star space infinity principal space I have delineated. Zeta does not exist. We would then want to simplify our problem by considering that a membership condition may also be typed, for instance, as logical consider. All right. Equalities there. Zeta of our pencil. And that's okay. So what are you saying?
I'm saying that, okay, so n being included in the non-existence of zeta corresponds to the typed representation not existing of n. But this does not entail that there is no typed representation of zeta or chi, because there is a type representation, and this is the negative representation, or not negative technically, but the negation representation, which is the nothingness instantiation membership. So just to say that it doesn't exist as a certain type doesn't mean that it doesn't exist as the nothing type. And so you can't equate it with nothingness. And so a pencil that does not exist means that there's a fictional, it exists as the fictional type, but it's not enough evidence to call something nothing, because there is a fictional thing that does not embed into a real world. It's not a good enough nothingness candidate.
Oh, well, look, we summoned James. We were talking about paradoxes, and then he pops in here. I see you there. Welcome, Laura. Good to see you. Haven't forgotten. But all right.
Does that make sense?
What I took away from this, Ryan, is it sounds like you're working, and again, this is your first pass. You already said there's going to be a sequel. Sounds like you're going to be working on this more. We'll have to maybe contribute, or at least have you learn me some maths and everything, because I learned a couple of things today. Thank you for that. It sounds like you were working on a potentially formalized and, if possible, a rigorous way of proving that either nothingness is a thing or has isness to it, or by negation, literally just saying by defining nothingness as a type, we've instantiated nothingness as an actual type.
Yes.
Cool.
This is not.
No. It sounds like a fascinating. It reminds me back in the day, like playing like some of those, like whatever game it was, where it's like, all right, whether it's Killer Instinct, this or that, Mortal Kombat or something. If you actually knew how to do combos, like you could just spam the same thing, like freeze with Sub-Zero or get over here with Scorpion and stuff. But if you knew how to use some of the other characters really well and just like juggle and get all the timing down, dude, you could raffle stomp people, and it was crazy how good some of those folks were. And I'm talking about like even at like some of the arcades and stuff before, back in the day, like before you had all like those hours and hours of playing. You had to like put the quarters into the thing. But I remember with all that stuff, I'm just like, oh, well, finding a little trick, or even in Smash Brothers, it's like, all right, there's a place on the platform where you're able to get this extra advantage or something. The people that learn those little tricks, I'm like, so you're going at it by one way, but you also have this default, well, if this doesn't work, if we quantify it, if we say that nothingness is a thing, and we're basing on, well, if language is a fundamental, if nothingness is a thing, I mean, well, if we try to negate that, basically we could prove it by negation. I'm like, huh. I may have said that wrong, but.
Well, so nothingness being defined as the non-immersion of a fictional thing in a real world is the same thing. If we negate that, then we negate the real immersion of real things.
I like how you basically are using our own semantic stuff. No, this is great. No, I love those little tricks. I love those little tricks where it's like, this one obscure part of mathematics that we generally accept in everything could be applied in this other area that, I don't know, can it help prove that nothingness is a thing? I guess we're going to have to stay tuned to round 2 to find out.
But, I guess now that, I haven't even been thinking about this for a while because I was thinking about some other topics, but I think you've reinvigorated some interest in me. I'm going to have to definitely take another stab at this and write that sequel.
Cool. Yeah, well, that's the thing. That's the other thing. Just inspiring other folks, because everyone affects everybody. It's like, all right, there's a lot of crazy stuff going on in the world right now. There's a lot of chaos. There's a lot of just stuff and things that aren't too good. It's like, try to put some positive vibes out there into the world, and you can inspire, invigorate somebody. You never know who's going to come up with that next great idea. So it's like,
do you see James's comment there? I'm sorry to interrupt.
Oh, no. Right. By negating that which is negation. Right. By negating that which is negation of existence, we bring it into existence. That sounds like a very James thing. and we go back to, like you were saying before, what happens if someone just puts a link to the Bible? So it's like spoken like a true miracle. Well, you literally have notation in there saying that, well, in order to help get existence, basically we have the word. I'm like, I have no idea if that was intentional or not, but sometimes the best things just kind of work out that way.
If I write a sequel to this, which I am actually, there were some more rigorous mathematical constructions that used more category theory and diagrams that I called open and closed voids, and these were.
I feel like that would actually be a very people would read that paper just because if you could say something about voids and everything, I'm like, voids in a mathematical paper. What?
Oh
what
yeah,
is this?
yeah. I actually came up with the idea, but I was thinking about some categorical construction that could reify them and make them make sense in a context that's a bit more rigorous. And there would be two types of voids. There would be open and closed voids, and that's all I can say for now because I'm keeping it a little bit secret.
Okay, I have no idea what that even means, so I guess I'm gonna have to stay tuned and read the next one. But
Hopefully.
parting words for the folks.
My parting words, thank you everybody for coming here because I very much enjoyed being on this show, and it means a lot to me that you guys would come out to hear us speak.
Cool. Well,
have a good day.
Thank you all for joining. Peace out, everybody. Take care of yourselves.
Peace out and much love.
All right. Take care, everyone.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.